The figure shows a schematic of a simple watt governor mechanism with the spindle O1 O2 rotating at an angular velocity omega about a vertical axis. The balls at P and S have equal mass. Assume that there is no friction anywhere and all other components are massless and rigid. The vertical distance between the horizontal plane of rotation of the balls and the pivot O1 is denoted by h. The value of h is equal to 400 mm at a certain omega. If omega is doubled, the value of h will be, so we need to find out the value of h when the angular velocity omega is doubled. So basically this is a question from governors from the subject theory of machines. Let's look at the solution. We know that for a watt governor, the speed of rotation n and the vertical distance between the horizontal plane of rotations and pivot point is given as n square is equal to 895 by h. Let us consider that as equation 1. We also know that angular velocity omega is related as 2 pi n by 60. From this, it can be understood that omega is directly proportional to n. From equation 1, we can write omega square is equal to 895 by h. From this, we know that omega square is inversely proportional to h and h omega square is equal to constant. Therefore, since h omega square is equal to constant, I can write h1 omega 1 square is equal to h2 into omega 2 square. Let us consider that as equation number 2. Now from the question, in the first scenario, we know the value of h. Let us consider that as h1 is equal to 400 mm. In the same scenario, we have the angular velocity value as omega 1 is equal to omega. Now in the second case, when omega is doubled, it means omega 2 is equal to 2 times of omega in the first case, where omega 2 turns out to be 2 omega. Let us substitute these values in equation 2. We get 400 into omega square is equal to h2 into 4 omega square. Omega square and omega square will cancel out and we are left with h2 is equal to 400 by 4, that turns out to be 100. The correct answer to this question is option B.